Good afternoon, everyone. I would like to officially welcome you today on behalf of Academic Association of Faculty of Architecture. For those of you who don't already know me, my name is Victoria, and together with all these wonderful people who work with us intensely, we're organizing lectures about architecture to promote new ideas, discussion, extend knowledge, and learn about the design process. Of course, it wouldn't be able without our media partners that help us greatly to promote these events, for which we are very honored. If you would like to support us yourself, you may consider becoming one of our patrons on Patreon. We will put the link in the description of the stream. Tonight, we are pleased to welcome our speaker, Mr. Roger Riewe. Roger Riewe is a professor at Institute of Architecture Technology at Graz University of Technology and the CEO of Riewe Architektur. Many of you probably had the pleasure of visiting Seleucian Museum in Katowice, which he designed. His and Florian Riewe's studio has won multiple world-renowned awards, and in 2016 has been nominated to the Mies van der Rohe Award for St. Agnes Church in Berlin. His work concentrates mainly on the sensory experience of space and structure, being at the background of daily activity. In the field of technology, he focuses on new materials and their use in architecture and the demand for as yet unavailable materials as a demand of architecture. Please feel free to ask any questions in the comments below. Mr. Riewe will answer them during the Q&A at the end of the discussion. I'm honestly eager to see what he has to share with us. Now I would like to give the floor to the Dean of the Faculty of Architecture.
Thank you very much. This is my great pleasure to welcome you all during this event, our guest lecture of Professor Roger Riewe. And I think this is a great occasion to meet, at least virtually, in our lecture series or meeting series, discussion series about architecture, which is already 5 years old, and this is the second time we meet during this pandemic time. We meet online, and today we are talking with Professor Riewe from Graz. And actually, I've seen some lectures of Professor Riewe, and during one of them, you said that you have many hats. German hat, Austrian hat, architect's hat, and academic hat. And I'm just curious how this diversity of looks, of perspectives will emerge in your lecture. And I'm also very glad that I welcome here a representative of Technical University of Graz, a city of students. When every fifth of the inhabitant is a student. Actually, now, as we were talking before the lecture, it's a bit less because students went home and are working online, but still is a great academic Austrian city. So thank you very much for joining us, and thank you, Professor Riewe, for accepting our invitation, and I will leave the floor to you for your presentation and lecture. Thank you very much.
Okay, thank you very much. So we're switching over. Okay, I'll just now we'll have to share the screen, so you have to then make it possible. Yeah, and thank you very much, dear students, for inviting me, and dear Christoph, Dean, thank you very much for the introduction, which I really appreciated a lot. Get this organized. And let me refer to your comment with the different hats I'm wearing. Actually, this has a certain background because due to my private situation, I actually got used to wearing these different hats because I'm German by birth, but I grew up in South Africa, so I'm like German, South African, but also like Austrian, so always like crossing the border. And since then, I'm always like interested to see what is behind the border. So I'm never really just satisfied with my situation where I am at the moment, but always, you know, what are the others doing? What can I see? What can I learn? So different kinds of cultures, different languages. I grew up like trilingually. And so with the language, you also get into the culture of other countries. You get to know how they're dealing with their everyday life. And so it's always a kind of international approach, whereas I don't really put any stress on internationality because it is absolutely normal. It's just the usual way of working. And so it's always the interest of, you know, the others, and also, as you said, Victoria, before, of different materials, of different architectures, which arouses my curiosity. And then I try to cast this into architecture. So with this lecture this evening, I would like to put forward a title, which is also the substantial contents of this lecture, which I would call Inherent Complexities. Something which is like a bottom line in our architecture, and especially if you see very different projects we've been working on, we have designed, we have done competition entries. Sometimes you might think, oh, but they look quite different. And where's the bottom line? So I would like to talk about this bottom line in terms of inherent complexities. So I would like to talk about a project you know and you referred to already, which is the Seleucian Museum in Katowice. A very prestigious big project, which was actually also nominated and shortlisted for the Mies van der Rohe Prize. I would like to talk about the new medical university we have designed and which is partly still under construction in Graz. I would like to talk about a huge car park for close to 3,000 cars located in the Hamburg airport area. I would like to talk to you about a gallery space or refurbishment of an existing church in Berlin, St. Agnes. I would like to talk to you about a huge event center, convention center for 20,000 people in Vienna. I would like to show you and discuss a project in Seoul for a museum. And I would like to show you a project, the Vietnamese German University in Ho Chi Minh City, formerly Saigon, and a housing project in Seoul. And finally, also a housing project, a big urban development, which is in Germany. Inherent complexities, something which actually goes by scale and which has different layers, but sometimes we cannot really divide these layers because everything goes like crisscross. But trying to focus on certain things, so I would say there's something like an urban context, there's an object context, and a detail context in terms of inherent complexities. But I will start off in a slightly didactic way, and I will leave this path as things will develop, and I hope that I can put my points forward as now set forward here with the header of inherent complexities. Starting off with a project, you know, the Seleucian Museum in Katowice, where you've got the urban fabric actually, or the existing urban fabric which we found, was like connecting the museum, which you see on the right hand side over here in this part, connecting it with one of the strongest buildings I know, which is the Spodek on this side. Here's the Philharmonic Orchestra House. And on the other side, on the east side, of connecting it with an existing park. So actually setting it, embedding it in a kind of important industrial, cultural realm, which at that time we only had the museum to design and the Spodek. This was not existing, and the convention center was not existing as well. I was actually a jury member in this project, a beautiful project which came along here. So how to deal with this as a kind of on a post-industrial site, which I think was highly interesting and caused our curiosity of how can we actually deal with this. So we said, let's give the city of Katowice not only a museum, but also public space, because we noticed in the city of Katowice, this is something at that time was still kind of underdeveloped, and Katowice was striving actually to look for something new, trying to define a new center and things like that. And so we said, okay, we'll use this possibility of connecting the park on this side with, say, the Spodek on this side, opening it up and giving a park to the citizens of Katowice, giving them something as a present, which is like unexpected, and contextualizing the museum with this site and with the urban setting. At the same time, you notice with this idea, on hand, building a museum on the site would be counterproductive, because the museum would block off all these ideas and you could not walk from one side to the other. So we said the museum can only be something which is very small or hardly visible, something which maybe, which we always like doing, does not look like a museum, so causing some kind of irritation. This was the design proposal, and finally in the build state, it looks just about the same. We were able to build exactly the things we were talking about and designing in the competition phase and implementing them in a built manifested way. On the right-hand side, you can see the bridge crossing the new road going into the existing park. And on the left-hand side, you continue walk to the Spodek. And there was a long discussion during the phase of planning if this would be possible, because the park area was known to be very dangerous, and if this dangerous area would then spread into the museum area. And we said, no, we are confident, because the moment actually you kind of generate a social control, then we hope and we think that these things will change. And I think we managed to do so. In the above part, you can see the existing old buildings, protected buildings, which will step by step will be changed into a cultural district. Another urban complexity, inherent complexities, an example is the Medical University in Graz. You see long bars, wider bars and narrower bars, buildings stretched out on this building site, which actually first moment just do not look like a university building. What was actually the idea behind this? The idea was that in Graz, in the city of 300,000 inhabitants, it's located, say, in a basin, and in winter we always have a problem of bad air because there is less air circulation and more pollution, and so there's always a big problem for this. So the air, the fresh air we actually get in the city, in the basin, and in the city of Graz is coming in through the valleys from the east and from the west. And this is one valley in the east where the site was proposed to actually locate the new University for Medicine. And this site was given because all of this you see here is the General Hospital. It's a huge area. It was one of the biggest hospitals in Europe. And so actually it made sense to have the School of Medicine, University of Medicine right next to it. But at the same time, the big problem of blocking off the natural ventilation for the city of Graz. So then we worked on the design, said, no, we have to keep up with the challenges of our microclimate. This is so important for us. And it's also a political issue. And we developed buildings which do not look like laboratory buildings, which do not look like university buildings, but finally are actually derived from the idea of saving the microclimate and letting a kind of ventilation, of enabling a ventilation through the whole campus area, which finally ended up having buildings of the size, big volumes where the air can actually go through, and with buildings not wider than 14 meters, the narrow ones are 6 meters. Which we think is very important. And also today, after the first phase has been finished, this obviously is quite successful, although we have not yet made any research on this case. But going with the microclimate, which is always like one of the things of interest for us when we start bigger projects, is the Vietnamese German university in Ho Chi Minh City, which is a greenfield design, a greenfield project. And we said, okay, it asked for a new university, including dormitories, including housing for all teaching staff. So it's like a small city. And so we said, okay, this is the actual design, which we'll focus on a little bit later. But we would like to reduce the use of air conditioning as far as possible. Now, Ho Chi Minh City is a tropical city, so it's very humid. It's not that hot. It's like 20 to 28 degrees, but the humidity is incredible. So you have to kind of cope with that. And we said if we want to try to reduce the air condition, we have to enhance ventilation, especially cross ventilation. So we took this whole, actually like a floor plan of the small city, and turned it with our energy designers in a way that cross ventilation would be possible, the main wind direction, but always having one side of the buildings with a wind pressure and the other side of the building with less pressure, so that there would always be in every building a cross ventilation as you go along. So this was the initial phase of the design proposal, after of course having the general layout, which then went right into the objects themselves. So whatever we were designing then was always like, please take care of the microclimate in this area, and we would only have air conditioning in the library and in the big lecture auditoriums, which were not possible to be made without air conditioning. But also the inherent complexities in terms of, say, the urban context, again, of embedding a project, which we think is so important. It was like this car park in Hamburg. I showed a picture before. Oops, sorry, I have to go back. Which is here, and which is actually bigger than the terminal building. There's a terminal 1, terminal 2, terminal 3. This is the old terminal. So this building is actually bigger than any of these terminals. And so how actually to cope with this, how to find a building which will be part of the whole airport area, of the whole built up airport area, but will be not stronger than anything. It'll just be like one of amongst other buildings. After completion, you see the terminal buildings in the background with the vaulted roofs, and the car park in the foreground, being as if it has always been in this whole area before. But it doesn't only mean that it should be like part of an urban real. We also think sometimes it needs to have like a special position, like the convention and event center in Vienna for 20,000 people, right next to one of the main highways leading around Vienna, actually from Salzburg, from Graz, Vienna to Budapest and Prague. So a lot of traffic, and this traffic, these are flyovers, so the highway is quite high. And this is the site, a site nobody actually wants to have because it's so hard to deal with. And we said, no, it needs like one big object, just one object, not what they were asking for, like 2 or 3 objects, one big object to find its position in this urban realm. And as a design approach, we said it's for 20,000 people. It's an indoor stadium where Vienna wants to be part of the game of European convention centers like Madrid, London, Hamburg, Berlin, and then so on. I think maybe there's one in Warsaw as well. I'm not sure. So they can actually host huge events like concerts, finals of ice hockey, basketball, or whatever. So we said, okay, then they really have to dig into it. And of course, it is not that very cheap, but at least to have this one big building, which actually then in itself is already showing that something special on this site is happening. But also in terms of urban tissue and urban context, the inherent complexity with a project in Seoul, where they asked for a museum in the midst of a park, and you see the neighborhood with huge buildings, high-rise buildings, residential buildings on the one side, lower buildings, school buildings on the other side. So how to contextualize a project like this in terms of urbanity, of urban context? Very difficult. So we say it's not only the part of the building mass, it can be, and it should be, if possible, something else as well. How can you use it? How can you utilize the building itself? So it was also the idea to see the museum itself, which was actually the exhibition on show as well. Staying with Korea in Seoul, we're invited for a housing competition, and we only had like 5 weeks time, and for thousands of apartments. And they asked for an area, in an area where you can see this here with a certain urban fabric, which are very small houses in very bad shape, and all of this was actually part of this fabric before. So these are settlements you have in Korea, which were set up from late 50s. So after the Korean War, as for refugees who came here and found some place to stay, who actually started squatting and afterwards built their own houses. So what we found is actually a situation where the housing, the quality of housing is really bad, but the social community is really strong. And how to deal with this, and this was also an issue for the local municipality. So it's about history. The inherent complexity here is about history. So what we said is that the plan actually of the existing settlement, which should have to be demolished, would be inscribed in our plan here. You see all these small buildings here, all these in the landscape design itself made by Agence Terre. So all of this are like retracing the existing settlement structure which we have. So it's actually keeping with history. So these people would have to move out, their houses would be destroyed, the new ones would be built, and they would move also into these new houses, plus of course thousands of new inhabitants. There would still be this idea of memory on this site. Which you can see here on the left-hand side here, where you see certain looks like ruins or something like this. These are actually retracing the former houses on this site, but now they're like vegetable gardens, community gardens, and so on. And the buildings themselves are all elevated. So actually the natural topography goes beneath every building, and the buildings themselves do not touch the ground. And coming back to Europe, to Munich, a big project we are working on at the moment, and it's for 13 hectares and 1,400 apartments, maybe about 3,500 people who will be living here in the southeastern part of Munich, where the issue was in terms of complexity of actually melting into the tissue of the urban fabric given. And this was very difficult because on the one hand, we have around here, settlement, there's the settlement, typical settlement, satellite settlement of the 70s. And on the other side here, it's a nature reserve. And here we've got single family houses. So just about everything. And now we have to try to find a missing link for the urban development for this area. So what we said is, let's go back one again. What we said is we'll take in this nature reserve as a park into the area, but a park which is not only for these people who will be living there, but a park for the whole neighborhood. So a park also for these guys over here, or for those who can come here and be in this park and go to the neighborhood, go to the nature reserve as well. And at the same time, trying to actually find a missing link between the small residential houses and the semi-block structures on this side and the high rises. There's 12 floors high, 14 floors high, and our buildings on this side. And finally, when you come up and you finish your plan, I'm always interested in drawing this in an early plan, like we did here. And I always think that the moment when you don't really see the new anymore, then the project basically should be actually quite good already. So of course, you know the project and you can find it. It's this part over here. But you see that the small structure here is part over here. The bigger structures is part over here. The landscape part goes right into here. So actually it melts into the general urban fabric quite well. Going into the next scale, as when you see the Nully plan itself, just the buildings in black, which is of course a very strong subtraction of what a city is. It's just, showing the building and the space in between. But of course we know a city is something else and needs more. But giving this kind of abstract position also shows us, with this image I show of Katowice now, where in a quick glance you actually then can connect these cubes we have here with these buildings over here. All of this is the landscape in between. So you can read it in terms of a Nolly plan, and then you start thinking of how actually can this whole area develop on further levels, because only black and white is not enough. So the interpretation we had for this site was to say, as you probably know, that Katowice actually developed around 3 coal mines. And so there was always a lack of a center. And the site here given for the museum itself, Seleucian Museum, was also a former coal mine, the mine called Warszawa. And what not in use anymore. But what we thought of was that actually there is an everyday culture in the city of Katowice, also especially in Silesia, where a lot of working culture is underground. So it's very specific. These are very specific people as well. We know them in Germany from the Ruhrgebiet. A very strong community actually, which exists due to having to work together underground in a very dangerous realm. So we said, okay, we can change the paradigm. We use the paradigm, change it as well, and say, now instead of working underground, we put the culture underground, because we dare actually to make it, to propose this, because the people have a, say, positive connotation with that which is underground. In other areas where probably there are no mines, the underground is something dark, dirty, wet. But if there is a working realm underground, it is something positive. It's hard work, but it's labor, gives money, and you can afford a living. So we said, okay, let's go for this and see if we can change this paradigm and put the museum or the most of the functions underground. Excuse me. So of course, how do we get the visitors underground without saying you go into the dark? So it has to be something very special. You have to take them down on like a catwalk into this museum, and so they can visit the different levels. And at the same time, when you go underground, there also has to be a vice versa, also going up again, of having, say, the voids, like these atrias, but also like the cubes coming up, built up. And actually in these cubes, there's no museum. It's just for daylight and for ventilation. So then you can actually say, okay, these cubes, they can become abstract because they don't have to be a museum. They just have to fulfill the function of ventilation and smoke fumes and getting daylight below. And this is the thing where we say we enjoy this irritation because there's no sign saying this is the Seleucian Museum. So you would have to find out, you're curious, what is actually happening here? This can be just something, but at least not a museum. Can't imagine this to be a museum. And this was the initial model. Sorry, we did for the competition. This was the model in the office. We only had these cubes. And we said, yep, we don't actually need more. The whole museum, all the exhibition space, everything is underground, and we'll give back, or we'll give a park as a present to the citizens of Katowice. So it's just as one very strong approach, daring approach of how to see a museum. And coming back to the ideas of these cubes, that's the medical university in Graz, where explained the idea of having, of checking the cross ventilation, of letting the airflow, the natural airflow go through these buildings. So all of this is the new university. And this is actually just for bachelor students. So we don't have any patients here. The students are just trained in laboratories. And finally, when you're a kind of master student, you go to the hospital area and you're also trained with patients. So in this building, we have a lot of laboratories and lecture halls and seminar rooms, and of course, offices, institutes, and a huge area for research. This university was founded in Austria in 2003. This was a reorganization of all universities in Austria. And so we were kind of, in a way, privatized. And all of a sudden, as a coup d'etat, there were 3 new medical universities. And this is actually the first medical university which was built new. 2003, the plan, 2004 planning, actually conceptual planning for a new university began, and the first phase was completed like 2 years ago. So there's students in here already, not now because of Corona. And in this short span of developing a new medical university, this university has been ranked as one of the 10 best universities worldwide which have been founded in the last 10 years. So it's incredible the approach they actually made. And it's also a lot of enjoyment and fun talking to these researchers and highly intelligent people of developing a campus like this. But then there are also like certain points I would like to show is how to develop, if you start designing these cubes, of how to develop these cubes in further detail. And this is the point I just showed with the elevated building itself. So we've got these cubes. This is the 6-meter cube next to aligning the 14-meter cube, and a big public space on ground floor level. And of course, when designing a cube like this, we would like to enhance it as well. So the discussion is, of course, where to put the column. The columns which you see here, if you put a column here, which your engineer would most probably propose, then the column, of course, is part of the cube here. So the moment you put the column inside, away from the outlining part, then this becomes independent and the cube itself becomes like an independent form. And when you then still like put these columns in inclined way, then they become a topic of their own. So actually, we were fascinated that our engineer said, okay, you'll try to make it work because still it shouldn't fall over. And it has become something like an icon in this area, because everybody's talking about these very strange columns, as they say, spaghetti columns in this university campus. And along with this goes, of course, the further development of these cubes. This is also the thing where we have fun with it. We say, okay, we say A, then let's say B, let's test it. We can say C as well, and go along and say, if we have these abstract cubes, then the window is always a problem and the door is always a problem, because these actually give a hint at scale, and we don't want to have a scale, say, in an abstract cube. So we started developing these facades which open and close in a kind of bionic way. And finally become something very abstract in the neighborhood. Is it like a wall, or these cubes, or what is actually happening here? Where are these shades of gray coming from? You see a big hole, but in this building, the Chinese would say it's the place actually where the dragon can enter the building. But of course we don't have any dragons here. But this facade is moving all the time, depending on the sunlight, the direct sunlight. And at the moment there's no sunlight on this facade, so all the window shades, all the brise-soleils are open. But when the sun comes, then everything closes, but people can actually open them individually. So this is the part where actually we continue with our inherent complexities of really kind of massaging a building at the moment we have it on our tables and working on it. And this is the fun part as well. Staying with the abstractness of buildings, it's also a topic of how to make huge buildings small, the play of perspectives, the play of being it part of the neighborhood, part of the structure of the neighborhood, like here taking up lines of the neighborhood, because we did a lot of research with this site before going in for this competition. We said, okay, there's lots of these lines of mobility, of speed, of say 80 kilometers, 30 kilometers an hour, and so on. Let's take all these ideas into a car park, as we have, as you can see here on this image. And this is only possible with when actually the moment you design a thing, this can be in the scale of 1 to 500, maybe even 1 to 1,000, that you already have an idea of what the facade can look like and how to actually work on the facade to make this again possible as a whole, as a kind of holistic approach for a building itself. So this was an initial concept for the facade of saying the facade itself has to be as curved as the building itself in its floor plan, and it has to be it has to have a substance as well. At the same time, there should be an open car park. So 50% of the facade has to be open for cross ventilation. So you don't need any mechanical ventilation in the building like this. So this was something we proposed, and had, of course, to try to convince the owner of this car park that this is a good idea, where it is actually looking far more expensive than the usual car park. So we had these, we were able to convince the client and of having these curved prefab elements altogether, like 11 kilometers, 11,000 meters of prefab elements on this facade to give it actually this very special appearance. They went with it. To actually then see a building like this, because if you would imagine if this would be like straight pieces of concrete, this would not look that good. Coming to the church, or the former church of St. Agnes in Berlin, now actually known as the König Gallery. After the fall of the wall in Germany, a few years later, just about 100 churches were for sale, and so you could buy a church. And this is actually what the owner did, Mr. König. He bought a church, a kind of brutalist church, fantastic building, which is listed. It's a historical monument built in the 70s. And the brief actually asked, or he asked for, we have to double the floor area so there would be enough exhibition space in this church. How to go about this is when you actually already got used to this fantastic space and now you have to change it. So we said we would only take one measure. To double the surface area inside would mean actually to put in one floor, and this is actually then put in like a table, just like an, say, ordinary table, a table with legs. And this would be the new floor inside this church. And this we put forward to negotiate with the local departments, because the building is listed. It was not so very easy, and long discussions actually faced us. So we put this church, the table here. You see this line along here. This is it's a balcony, which you could see in the slide before, for the choir and the organ. And we had to keep this balustrade because it is needed structurally. So we had to be on top of this. This gave us the new height to actually take the table along here. And this is the area of the altar with the skylight over here. So the light would come in here. So we didn't change anything of the ceiling. Just put in this table with the legs. That's all. Appears to be quite simple. Due to the fact that the building is listed, we were not allowed to make any foundations, because they said maybe in a few years' time this will not be a gallery anymore, and you have to take out everything and make it be a church again. So this is the way we actually then made the non-existing foundations, and they said, okay, we actually wanted to make a table, so a table doesn't have any foundations, completely clear. So we could actually focus on that and articulate the idea of a table. And at the same time, also going with the idea of the table, was the thing that actually the side walls, the concrete walls, are not load bearing. So we could not attach the new slab we would put into the walls because of them not being load bearing. So all the weight is on the load bearing columns, say on the legs of the table. So there's a joint between the plaster wall, which you see here, and this is the table itself over here, which is 20 centimeters, and everything we need for technical appliances is in this concrete slab, a monolithic concrete slab of 20 centimeters only. So that's why you can see along here a joint going with the facade, with the plaster wall. So all of these walls are not load bearing, which is actually surprising. And what we put in is a concrete floor, as I said, monolithic. And we were actually asked to do this in steel. So we would see, you could see the difference in an, say, existing historical monument, that you can see the difference. And we said, well, this is the Charter of Venice. We know that you have to go like this in your planning process, but we think that this church itself is so strong. It's by Werner Duttmann, a good architect. I think it's his strongest project, and he then became head of the urban planning department of West Berlin at that time, and we cannot do any better. So we'll try to make it look as if it has always been there, and only the details are different. And this was a very kind of intellectual talk we had with these departments protecting this church, and it was really fun at the end, in the end, that we actually could convince them of the ideas we had. So we've got this joint, and we've got this table be made out of concrete. And the joint, we then notice, because the facade, the walls are not load bearing, the topic of the joint is all over. There's also a joint here. All of a sudden you notice, okay, Duttmann also wanted to show that actually these walls are not really concrete, it's just plaster, like a false wall. And so we've got the joints along here, and we've got the joints along here. So all of this building actually exists of joints, which you then finally see in this section. This is the interior wall, and there's a cavity, and this is the load-bearing wall on the outside, and goes on both sides, and you see our table in between here. So it suddenly becomes very clear, of course, yeah, you cannot attach anything to this wall. And in former days, when it was still used as a church, they would heat up this cavity on Sundays, and so that was okay for the people attending the mass. But during the week, there was no heating in this church. But when using it as a gallery space, you would have to heat up the thing every day. And then, of course, the client, Mr. Koenig, was worried that he would go bankrupt in a matter of a few weeks or months, or at least after the first winter. So we had to take out the heating and put the heating in the ground, in the table, and in the new ground floor plate, which we cast in situ. So also the dimension of these joints became an issue, because this was an existing joint where we're now above the balcony where actually the organs were. And this joint was existing already because Duttmann also did not let the balcony itself be attached to the plastered surface. And this distance is actually bigger than allowed. It is 5 centimeters, so actually you can fall into it, or something small can fall into, or a kid's foot can fall into it, but it is actually a listed building, so we're allowed to do it with this dimension. And when you in the space on ground floor below the table, space which actually should be used as a depot and storage for artwork, but has not been used like this till now. And you look up and you see the joint again. So all of it, at this moment, you actually become sensibilized for the joint as a topic in this building. And it's not only that you see that there's actually a detachment of the concrete slab in the existing building, but also there's an acoustic connection. You can hear the people from above when somebody's talking upstairs or when somebody's talking downstairs. It becomes, or it stays, actually one space, which is rather fascinating, something we didn't actually think of and imagine when we were designing this intervention. We then had to add an emergency staircase on the outside. And again, we said, okay, in our whole building, nothing is attached to the concrete wall or to the fake walls. So also the staircase itself should not be attached to the existing. And we have to go up to the first floor. So we designed a staircase, which is just one huge cantilever. So there's no column and no attachment to the facade. So there's a huge foundation below this structure. And as you can see in this part here, that the ground plate is actually thicker, and then it goes up here and becomes a cantilever here, and the whole balustrade itself is part of the beam as well. This is something we were able to do because we've got a fantastic client who really enjoys these intellectual discussions. So you see the staircase here as if it has always been there. Just like the table inside, also this concrete staircase looks as it has always been in this place. And you can see the joint along the facade. It is detached. It's just one big cantilever going around the building. And the balustrade itself is, of course, part of the cantilever, so it's the beam. Otherwise, it would just not work. If you have a closer look at, you say, well, this is an ordinary concrete work cast in situ. The formwork is actually very clear and very precise. You see all the edges are 90 degrees. And this is something which actually makes the difference to the existing building of Werner Düttmann, who treated his concrete surfaces in a different way. Like, for example, in the bell tower, which is also the main access to the upper floor, you see the concrete work with rough shuttering, and you see the edges are 45 degrees. And this is the way he would treat it. So all the new concrete work is actually a very precise formwork, very smooth, and always 90-degree edges. And then we said we also would like to take the handrail, because it's great, it's fun, because you can't actually do these nowadays anymore, because these handrails always have to be a rod, it has to be round, but this is a square. And we used it for the staircase outside. You see on the right-hand side. So this is actually a Düttmann handrail, but with new concrete work. So the concrete itself is always 90 degrees, very sharp, very clear and clean formwork. So it looks completely different, but only to be seen by, say, architects and, of course, the audience now listen to my talk in this detail, which we have been using here. So it is an highly interesting complexity in this project, and finally it looks so very simple. So coming to these details so I would like to come back to Katowice with the big cubes which I showed you in the model for the competition. Well, we're sure there should be these like translucent illuminated boxes, and at that time, of course, we did not have any material, an idea for any material yet. And then when designing the project itself, we came across a glass, which somebody is producing in Austria, and actually has got a patent on it. And this glass itself is actually something which just happened by coincidence. And they were so fascinated by making this glass, and we were fascinated to see this kind of glass. Said, okay, this is something we can use. And you see the pattern on the glass. It's like Ice Age fawns implemented here, but they cannot control the texture of the glass. So what they do with the glass is they make float glass, and then they melt it again, and then they put it into, say, a fridge, to say it very simple, and then it starts cracking. And so you can only order 40%, 60%, or 80% translucency and nothing else. And we were fascinated by this, that we can only distinguish the degree of translucency, but not the pattern. Although the pattern looks so designed as a kind of floral pattern on these cubes, which actually then fit to the surrounding landscape. But by using this kind of glass, we were then able actually to transform this idea we had in the competition already, having this translucency. So it's not really closed, you can still see something behind. It's like, you know, a certain shade or something which kind of generates curiosity, and this is something which we really enjoyed when using this material and implementing it. And then of course this kind of floral pattern goes with the landscape itself, which I showed from aerial view before as a reusing a post-industrial site, saying that you can actually use these huge surfaces by putting in a new kind of vegetation which is local at the same time. And these, the organization of cubes, of course, is dependent on what is actually below, which parts of the building need the daylight and where, but also at the same time you start making something like an urban morphology in the landscape you are designing, which is highly fascinating. It's a play of perspective, play of letting roads go, paths go through them, and also a play of of scale, because it's hard to figure out in which scale we are working in at the moment. This takes me back to the university project, the medical university project, with kind of the same idea, but not working with the translucency, but with the abstractness and the idea of perspective, of creating space. Those who have been designing laboratory buildings know that there's actually a kind of grammar behind them, that due to the space in the laboratories you've always got like a grid or raster of 1 meter 15 or 1 meter 20. And we used 1 meter 15 here. And all the elements you see here are like parts of 1 meter 15. So it's not only the interior, but also the exterior. Everything goes along and everything coincides. And then to make a big building small, again, this idea of Katowice in a certain way as well. Here we said usually, or very often, the sky in Austria is not blue. It's maybe gray or cloudy. And so we took up pictures of clouds and pixeled them, and used like 6 colors, 6 shades of gray for this facade. And we wrote an own program for this, and of actually having the facades be something like pixeled pictures of clouds. So with the background, it starts actually melts with the background, as you see it here. When you've got a gray background, of course, when you've got a blue background, the story does not really work well. And then with the program itself, it's always, if you've got 6 shades of gray, it's always 1, 2, 3, 4, 5, 6. And it's always like 6 next to 5, but not 6 next to 4, because then there would be one jump too much, and this would look like a mistake. So we've got 45,000 panels in this building in the first phase, which of course was only possible to make with a program. And of course, a lot of effort had to be put into the planning process, and of course the process of construction, because you have to find some way for the workers that they put the right panels in the right place. On the other hand, we also said that we want to have these like closed facades at certain times when the sun is on the facade. So the brise-soleil itself, this bionic approach, lets this facade actually close on the right-hand side. Now everything is open also in this facade in front of us. But in the back, you see like open windows. This is the part where the buildings are very narrow to each other, and we don't need any brise-soleils here. So something you don't think of, it's all over the same. It suddenly becomes very diverse as you go along. As you can see here, with the opening on the right-hand side, an intervention on a piece of art by an artist, Esther Stocker, actually picking up the topics of researchers in this building complex, saying that you scribble something on a piece of paper and you just want to throw it away in the dustbin, and this is the moment when it actually goes into the dustbin. And so these are like huge pieces of paper where you have actually scribbled something on. So it's actually a very nice connotation in this world of research, of sciences, and of medicine. going further with actually then developing these in this abstract world, these open spaces, the play of voids and solids, here with the view going over right to the area of the existing local general hospital. Fantastic view. We're actually now under construction. We have the second phase of this university complex. And only at the second glance would you notice that there's a piece of art right up here by Markus Wiefling. And actually the more sculptures of them actually showing this is the old man, and then you've got the corpse, the skeleton, the whole life cycle of a human being, and also being part of this medical university. And he actually took up the same colors of gray, the same shades of gray for his sculptures, and then changed these sculptures in a certain way that they always look at the people down below here. So it's slightly scary, but highly interesting that there's a dialogue possible between the people using the public space and the pieces of art. View from the outside, then, where you can actually see in a second glance actually more of these sculptures just hanging here, and you also didn't want to have any special floodlights or something. They should just be like stalactites coming out of this building and being part of the building itself. So it's something which is, I think, highly interesting then in a certain phase to work together with artists in a building which is very strong, which they also said it's so strong that it's hard actually to be part of it. But finally they have to work for it, and I think we have got fantastic pieces of art in this building. And the third one is by Matt Mullican, with the biggest piece of art he ever made in his life till now. And so you notice that there's another layer coming in. You've got these, say, we can talk about very abstract architecturally designed buildings, but they become all of a sudden, slowly but surely, something like a background for utilization. That, of course, you've got the rooms of function, you've got labs in here, you've got offices in here, but there's also something like public spaces, and where there's some freedom of utilization where not everything is actually given or said or claimed how to use the space. Here in this facade at the moment, you can see the moment when there's sun on the facade and all the sun shading elements close automatically. Coming back to our car park, of how to build a huge structure like this with a strange form, which just doesn't look like a car park, because car parks are usually built in a way that they're very cost efficient. And so they can make a lot of money. So this one looks a little bit different, but of course the challenge was on the board, on the table, that it has to be cost efficient as well. So what we did is we proposed a system, a structural system, which can be highly efficient, which only has 2 spans of concrete prefab elements and 3 lines of columns in this whole building. So there's only the column on the outside, the column in the middle, and the column on the inside. And then this radius here and this radius here are the same. So all of these elements are here and are here the same. Only this radius is different. And then of course the straight pieces are the same on 3 sides. So we've got a huge amount of same elements, prefab elements in this building. So we could actually convince the client this is not more expensive than an ordinary car park in, say, rectangular shape. But then the client came along and said, can't we do it even more cheaper? And for example, instead of just having 3 columns, why can't we have 4 columns? Because then the span of the slabs would be less, and of course the dimension of concrete would be less, so the use of concrete would be decreased, which is right, and then you're having less concrete in a building means so it would be even cheaper. But then we said there's a problem coming along. Sorry. Wait, I have to go back one. That in our proposal with 3 columns, 1 in the middle, we are actually quite free in parking in these curves, right? You see the car here is not always on the other side of the car on that side. The moment we have two columns here, we can only park in between the columns, right? So this is actually a problem coming up. So in our calculation, we said if there's just 3 columns, we have got 494 car parks per floor, and if there are 4 columns, 473. So finally, we as architects, we said our project is more efficient because there are more cars which you can park here. Finally, the client said, well, you're right. If you calculate in a way that the car park is filled by 100% every day and 24 hours, but they would assume that their car park is filled by 75% in an average of 24 hours. So the car park is never full. So the right side is more efficient. Something very fascinating for us as architects. We said, okay, you win, and let's do it like that. So the construction was then made in that way. It was even cheaper. Showing it from the inside, maybe you don't even notice the difference that we now have 4 columns instead of 3, because the span itself is quite huge in any case. And the second challenge we were given by the client was that they did not want to have any joints, because they say the joints always have to be maintained, and then there are many kilometers, thousands of meters of joints in the building. So they wanted us to cast the concrete slab in one piece, which is 12,000 square meters in one piece of solid concrete without any joint. This is technically possible, but at the same time, as I show here in this image, there are constraints coming up that this whole building starts to move and to reshape itself due to thermic influences. So when it's cold, when there's sun on it, maybe even wind coming along, so this whole concrete slab starts moving. So actually the whole building had to be redesigned due to the fact that this whole building is moving all the time. Which led right up to one of these, for myself, one of these fascinating details. This is the concrete wall you see is the vertical axis of the shaft of the elevator. On the left-hand side, you see the column. And we've got a joint. The joint in a normal phase status is 8 centimeters wide. And then it can open another 8 centimeters. So the joint will get 16 centimeters and it can close down to 0 centimeters. So we're actually develop this joint in the building. At the same time, we have to put up a balustrade, because the moment the building actually contracts and we've got a joint of 16 centimeters, then something can fall in, or your dog or your suitcase or whatever can fall into this joint. So it's highly interesting, this complexity of a structural approach, say, of the claim a client puts forward, and then you as an architect still have to solve this problem. And finally, you see this building like a very abstract, big structure, actually going away from a building, being more like a structure where you don't actually notice all these challenges inside this building, which we as architects in our office find highly interesting to work on. So it's always about the certain measures we put in these buildings, which we say let's go for it. We have a team, and then we talk about these things in the team, and so suddenly everybody says yes, okay, let's have it, let's take it. So in this design proposal for the event arena in Vienna for 20,000 people, we had a case study given, which was this one here. It says you've got the arena itself for 20,000 people and all secondary functions aligning it like this. And when you're inside, you go out, you go through this building and you're outside. And we said, well, this is not really that interesting. So what we proposed was actually to take this aligning building and just to put it like 2 longitudinal slabs, sides at the side of the arena, and then creating a huge interior space. Then dislocating parts of this longitudinal buildings and having these columns, and then finally putting the roof onto the arena itself. So we are creating a vast interior space where we said, yes, we can do so, because it's not only that spectators visit, say, a concert or a basketball match or whatever, but also at the same time, you can use the interior space as a catwalk for the people who like to be seen, the people want to show off. Lots of things are happening there before you've got the event of maybe just 90 minutes. So everything was actually proposed to work in this way. And so also the facade itself on this side was developed like a big curtain. So this is actually where the curtain opens, this curtain here. Of course, it doesn't open in real, it's glass, but made like a huge curtain. And all of this is then the stage. It's not only inside here, all of the building becomes stage itself. So this is the interior space then with the left-hand side, the arena, where you can actually go in. You've got the VIP part over here with the units, certain units. You've got all the restaurants and bars on this side, and you can come up here with huge escalators, pairs of escalators, walk around here, and then go into the arena itself. And you've got this big space, mutual space for the audience. At the same time, the roof itself has got this vast span. So, of course, the structure of the construction itself is very high. So what we said is proposed that part of our program, of course, the technical facilities, HVAC and so on, solar collectors, PV elements can be in the roof, but all of this over here is actually the hotel they asked for. So there's a big hotel they're like always 2-floor buildings up here. And this is a hotel inside the roof for the arena. And below there's still a triple sports hall underground. And this is the main entrance area for the people to go in. This is where the glass curtain is, and you go in here and you go into the arena. Which actually gives the impression from the outside of this vast building, where in the roof itself, you now notice it's not just a roof. This roof is loaded with utilization. It's the hotel up there, and in the big columns we've got offices and service and administration for the arena itself. And then this vast space in front as a kind of covered space, we say actually this is like the public space going indoors, but not indoors yet. And then you've got the big glass curtain, and finally you go right into the arena space itself. So it's not only for, say, looking at the people playing the basketball match, but it's also like the excitement of being in this place, which we thought was so important of creating arena of this dimension, say, in a European network. And with the museum itself in Seoul, we said, can you contextualize actually this building or this the brief itself? We said it's more like an we call it an urban living room, right? So all of this is actually, we design an urban living room, and only the rest, so to say, the rest is the exhibition space itself. So it's actually the public area, the semi-public area between these cubes here, which we thought was far more important than actually the cubes themselves, which can be very abstract. So you can actually walk through this museum, you can have some coffee here, you just can enjoy your day without actually visiting any exhibition, without having to pay. And this was actually the idea which took us through this whole project, to say, okay, you've got more or less this cafe lounge area for the whole neighborhood, where if you really are interested or you are curious, you can go into these cubes and find out what has been exhibited here. And when you go to the outside, you notice actually it doesn't really look like a museum. Maybe it's more like a restaurant, or, well, you don't know what. There's a piece of art still in the garden. But it's again this phase of irritation. We say this is interesting for the people who really like to find out what is actually going on inside. And coming back to the VGU, the Vietnamese German University, where I told you that we actually turned this plan into the wind so that we would have a strong or very good cross ventilation with pressurized facades and sub-pressurized facades. In the middle, in the organization itself, we said in this part here, we've got all we've got mainly faculty buildings. And here we start, here we've got faculty buildings, and these are dormitories here. So this is housing. These are faculty buildings. These are faculty buildings. All the fat ones are faculty buildings, and the rest are dormitories, and professors and teaching staff are these small houses here. What we have here is a ravine leading through the area, which only fills up with water when they have the torrential rainfalls. And then as a form of organization is this like a broad walk or broadway going through this whole area, and actually giving a form of orientation. So what we have in the middle is no square, but it's just an area of water or swamps or whatever. So it's like, it looks as if it would be the center, but it's not the center. It looks as if it would be like a square, but it's not a square. Going into detail, you can see that this is the square itself, which is the ravine. Finally, it's just landscape. And next to it, we've got the faculty buildings and the housing. So these are like faculty buildings, lecture auditoriums. This is the library. And all these with this floor plan are all the dormitories for the students living on campus. And I would like to focus a little bit on the energy design for the dormitories themselves, which fit actually into this whole system. This is the main square with just subterranean, where at parts there will be just water in here, and then parts when there's not the rain, where you don't have the rainy season, it's dried up and it's maybe swampy, maybe even grass, again made by Architekturze. And again, the elevated buildings where cross ventilation is possible. So a lot of ventilation in this area is made possible, so we don't actually put all the buildings to the ground floor, always taking into consideration the climate design of the whole campus. Leading right up to the idea, having these also in the high-rise dormitories for the students, which you see here just as an example. The dormitory itself and the kitchen area on this side, and the floor upwards is on this side. So everything is outside. Only the dormitory itself is inside, the access balcony on the side. So actually there is a possibility that the air can flow through here, which you can see in this section, that everything is completely open and only that part is closed. So we can do without air conditioned or mechanical ventilation in these buildings. And finally, you see these buildings on the left-hand side, on the right-hand side for this project itself. Also then, again, playing with the thing that we have very small privatized areas, but the rest is actually always like semi-public and public for all possibilities or most different possibilities of utilization by, say, a public or by users we don't know, and we don't know what they would be doing there. So it's completely open. Which again is like a design strategy for the housing project in Seoul, which we did with 9 other architects, which I invited for this project in just 5 weeks of working. And we said, okay, to be that fast, first of all, we have to be friends, and then we just need a few principles, design principles, to be really fast. So every architect was given actually a site, and we said that there have to be a maximum of 18 floors, and that you should not touch the topography, and that the living room and the master bedroom should be facing south. Of course, you have to keep to the codes of Korean standards and rules and regulations, that's clear. But this was just very clear, and so everybody could actually work in a matter of 2 weeks on their own design and then put it into the big design proposal. For example, Lin Architects, who designed something like a atrium house, or a project we did then designing in this way. So actually the floor plate was always the same, and also the 18 floors were the same. And we were intrigued how different actually the architects would approach this project, and always have the same amount of apartments. So I have like 2 buildings here by Sadavuga from Slovenia, or terraced houses by Brandelhuber and partners from Berlin, or having a big Z by Mangado from Spain. So it was fun, really fun working with all these architects in a very short time. And then you see the whole conglomeration of buildings, very different, but actually with the same bottom line, that the topography is actually one topic here of history loaded, and that the housing scheme itself can be very individual, but again with the same ideas, the same principles behind it. Which is also coming back to Germany, the idea of how to run actually these big projects of vast scale, like these 13 hectares or 14,400 apartments for 3,000 to 4,000 people, and where you know that you as an architect, you will not deliver all design services. So what we have here is actually, as I spoke of before, with a big park in the middle. We said first create a park, but we've got a big street going through here with a bus route, 2 bus routes going through here. We've got 2 high rises. This part we are designing right now. We've got a big promenade. We've got a block over here. We've got a creche over here. It's a project we designed as well, and it's under construction at this very moment. So it's all about a city. What is a city made of? Of course, you have to provide space for housing, for living, but you need also the space in between where you cannot really define beforehand what will happen there, but you need the space. So actually, different kinds of utilization will be able to take place. So it's also up to the structure of the blocks, which you said are not really closed blocks, but they are open. So you can actually always go through a block. At the same time, it's like semi-public, because all these blocks are, the interior here is 60 centimeters above that level outside. So actually you have to take an effort to go in here. That's car free, no car can go into here. So it's really pedestrian area, playground for these kids over here. But of course, if you want to take a walk, you can stroll through this whole area. And to actually have it in a reduced form, that you say it's important just to build the mass of the city, and the rest can develop, of having a ground floor along this promenade here, where we say these are facilities where you can have bike shops, cafes, youth centers, and so on, which are absolutely public, and the height of the ceiling is higher than in the floors above. So these possibilities right up to an atelier are possible in this part of the project, which is actually only dedicated to this part over here, this line, which I just showed. There was an image of this corner here. So all of this ground floor area is public, of course, here as well. Then we've got the creche here. Then we've got another kindergarten here, and then the street going down here. So this is a very important point. Here we've got a supermarket inside here. So it's, and a promenade with long discussion to say, why don't we put any houses here? Actually make it more feasible. We said, no, this is like the sunny side. It's like a big lake here. So it's open, so anybody can come here and walk into the park and walk into the nature reserve on that side. So a lot of effort were to be taken to convince the municipality, to convince the client that this is a possibility of creating a very attractive public space, something which is where we don't have any comparable examples. So we also convinced the client actually to start developing the park right at the beginning, when actually the other projects are under construction, and which they actually accepted, because trees take some time to grow, and also the grass pitches and so on. So this is actually the one high-rise building we're doing, and the housing project next to it with a kindergarten on ground floor level, so public services, which we have here. And the high-rise itself on the corner with actually, as we say, only with 2 details. We've got 2 edges which are round edges, also with the glass going round, and 2 edges which are the acute angles, which are sharp edges. So it becomes a very interesting shape, and also in terms of perspective, it becomes something quite intriguing alongside this promenade. And here again, also the ground floor level itself is completely public. This is very difficult actually to convince a client who usually just invests in housing that they can also do something else than just only building apartments. Long processes, but I think we're in a very good state now. So we need this very specific element in our buildings. So we always try to work on the background, but they always have to, they always in a way very specific. Like this is the courtyard of the car park in Hamburg. And we found out that this space has actually been used for special events, not now during Corona, but before Corona, because they found the space so very attractive and so strong that different like concerts or parties and so on are hosted in the middle of a car park, something you could never imagine before. But also if you go to the rooftop in the spiral and a little bit higher, there's like a well-kept secret at this airport, something I cannot really show because it's not really legal, but we've got all the plane spotters up there having their own party area because it's right next to the runway of the airport, and they take pictures of aircraft landing, taking off there, and they post them on social media and start selling them and things like that. So it's a real like secluded party area right on top of the car park. And even the client accepts this and say, okay, it's something really interesting, and let's be open for things like this as well. So actually the architecture is, as we say, it's always like a little bit background, and it has to be like a stage for those utilizing it, for those using it. And this is the fun part when you actually finish your project and you suddenly see the people going in and using it without being told how to use it. Katowice, the big ramp system, or the outside with the elevator going up and where we got the terrific view from above. Or even like other functions coming in, selling food and stuff like that, because people would need this to just enjoy themselves in the area of this museum, of this park. So it's actually been utilized quite well. Or even just being in the sun, just enjoying the new park, which we have provided here for the city of Katowice. But it can also be, say, the very special space, like the gallery, where you have these fantastic exhibitions, fantastic artists, but we also know that they have yoga sessions here as well. Or the space below ground floor level, we actually the depot, the storage should be, there's no storage here because the space is so fantastic also for small exhibitions, but also for hosting parties, great events. Pre-corona, maybe after corona, this will be interesting and come back again. And this is the church from the outside, so you don't really notice the difference from before and now. Everything is just inside. It stayed the church as it had always been. Of course, we did some amendments where to repair it a little bit, was leaking, but you don't really see the changes on the outside. This is what we really appreciate. But it can also be, say, the spectacular building all of a sudden, like the car park, being completely different because it's so surprising in its appearance during daytime. But during nighttime, but at daytime we don't really see it anymore. It just becomes part of the landscape. So that a building, even if it is a built manifestation of your ideas, as different kind of images, different kinds of faces. Or the huge public, semi-public spaces of this university campus, which can be utilized by students, but also can be utilized by the public as well, those who are actually not using the university or the facilities of the university, except for the public space. It has changed quite a bit, although Corona has now stopped it a little bit, but will return. And then finally, these buildings can become a background, as we say, architecture as a background for everyday life, or trying to show, say with other words, that we try to define structures which are open and precise at the same time, and which are like frames for the complex flow of images of utilization. Thank you very much.
Thank you, Roger, very much for the presentation, for the lecture. Now is the time to start the discussion and the traditional Q&A. So should any of you watching us online right now have some questions to our guest, feel free to ask them in the comments. And meanwhile, I do have a couple of questions, and you've covered a lot of topics and projects from various places around the world, and I thought about a question. Well, starting from, as it is a lecture, a meeting hosted by the students and mostly for the students, my first question for you would be about the research, because you've presented a number of projects of various scope and various background, and I would be really interested to know a little bit about the research, how you get to know the area in which you are designing, and how do you respond to the context, or do you really want to respond to the context, and what is your approach to this topic?
Very important question. Thank you. I think it's important to know quite a bit about the context, about the local context, but it's also important not to know everything. So it's still open, like you can focus yourself, you can exclude something. Something I did actually when, in the last few years when teaching, and we take the master students somewhere to other cities, and then they're always asked to make videos, but not about architecture, but about, say, shoes, about cats, about motorcycles and things like that. And finally, all of this is put together like in a 30-minute video. So they're just fragments, incredibly harsh fragments of a city. But nothing about buildings, because this is something we see in any case. We don't have to talk about that, right? And so suddenly you become like you get an idea of what may be happening here, and it's completely subjective. But all this extreme subjectivity becomes objective as well, finally. And this is also when we think about the projects when designing in our office. It's usually a team sitting around a table reading the brief, and we start talking. We can talk for days, for weeks. We don't design, we just talk and talk ourselves into this project. And then sometimes we go and visit the site, or we Google, or we need some information, or we'd call somebody and so on, get all these fragments and start developing an idea. And then one of these days we say, okay, stop talking and start designing. And we know that like 5 people will make exactly the same design, blindfolded, which is incredible because you need this kind of level of understanding. And it's fascinating as well. Say, okay, this is the idea we actually had, and many things are open. So also for, say, the Museum of Katowice, it was this idea of the post-industrial side, of the underground thing. We were not sure if it would be successful, because we heard that this park is like, rough place, drugs place and things like that. And we said, okay, we make a park, we put in a little bit of light, maybe it's too much light for drugs. They'll keep on that side. And of course you need a client who goes with this, who says, okay, nobody knows if it's right or wrong. And then it's a good way actually then to get started into a project.
And speaking also of research and context, in general, if you were studying architecture right now, what would you say are the skills or competences that an architect would need to maybe not only to succeed, but to properly respond to contemporary needs and challenges? And I think that we will speak about the challenges right now in a moment.
Yeah, thanks, Igor. It's a great question. It's something we are actually talking about all the time at university, especially at my Institute for Architecture Technology, that we are sure that the method of designing and planning will change in the next 10 years completely. And now we have to train the students for that, what we don't know what will happen or how it will happen. but we know there's a big change coming up. The one is, of course, the planning tools we are using, say from, of course, 2D to 3D, from AutoCAD right up to BIM, right? And which is actually hitting us, and we don't have these phases of planning anymore, no preliminary design, no execution planning, all is packed in one package. This is one part. This is a simple one. But the more complex one is, we have to be aware of the fact that we as architects and you as architecture students are responsible for close to 50% of the carbon impact worldwide. 50%. So we are the messy guys. We don't have to talk about the guys flying with aeroplane. This is 3%. We are 48%. And we want to actually get to the climate control of Paris 2030, so that the climate rise is only 2 degrees. And the way we are working at the moment, we are in complete trouble. So we have to change our way of thinking, our way of construction. We have to change everything in the building industry from tomorrow, all the time. We cannot go out and say we will design a building and just think about nothing. So we don't have a energy problem, right? We've got enough energy. Poland is a little bit different, I know, because of the fossil energy being used there, but we've got enough solar energy, we've got enough wind energy, we've got enough hydro energy. So we just have to use it in the right way. So we don't have to put more insulation on our walls, make fatter buildings of styrofoam, so we can reduce the heating. This is not the issue. The issue is actually we are wasting our energy and, of course, polluting the world by producing building materials, right? So all the concrete we're using is a huge amount of energy being used, and of course damaging the carbon footprint and so on. So it's not the thing actually to say everything has to be made of wood, because this discussion has not ended yet. We don't know, but every part has to be more material efficient. Make thinner walls, make less material, recycle material, go in for cradle to cradle. Whatever you have in your hands, you're not allowed to drop on the floor. You always have to keep it. Whatever you have, keep it, and try to give it to somebody else. You know, it's like at a party, you can play this game. Don't drop it. You have to go home with the stuff in your hands. There's no waste paper basket anymore, no dump, no nothing. And only then can we, I think, really be able to manage the criteria of Paris 2030 with 2 degrees increase.
So would you say that climate change is the biggest challenge we architects face right now, or are there also other challenges which, well, pose a threat, and we should have them in the back of our minds when we are designing?
I think it's one of the biggest for sure. It's not only the material question, but also how do we deal with built development, construction. The issue is, of course, of densifying cities, of not spreading out to the countryside, of really putting everything highly efficient into cities and urban conurbations. And then, of course, we've got a, say, multi-cosmopolitan society, a society of high mobility, say until 1 year ago. But I think these things are coming back again, as we notice with students exchanging all the time. So we've got Polish students in Graz, there are German students going to France and so on. So everything is moving. So we have to actually start designing and thinking of a society which is multi-ethnic, multicultural, multilingual, and so on, and how to fit this into a building program, a manifestation of built projects. How abstract can it be? Because if I, for myself, and I'm like half South African, so I use maybe outdoor space in a different way, especially when there's sun, right? And I live in a different way. But also say other people coming from Asia, maybe even from America, or whatever, and how can they really feel at home in the realms we are designing? And I think this is a society which is moving constantly, which is highly fascinating, and we have to be able to find these structures, these frames, that this utilization by them will be possible.
So taking this into consideration, I would say that that architecture is becoming more and more interdisciplinary over the last couple of years. And which other disciplines or specialists would you recommend for us to take into consideration and to cooperate with when working on the projects?
Well, it's actually something which should begin in design studios at university already, and we do it in the office in any case, which is we always have structural engineers, we always have energy designers, we have landscape architects at our table. And then from time to time, depends on where we're busy, of course, traffic engineers, sociologists, people from politics and so on, giving us advice. So it's always a multidisciplinary team. So when starting off, we never know where we will end up. So this is fine, because otherwise, if you go to a building site and say, I want to make this house here, then you will always have to defend this house, which you actually thought of the first day. And it becomes very depressing that you're fighting or struggling a fight which finally you cannot win, or it doesn't solve your problem. And we think it's more interesting to talk with all these people. Of course, we've got in a way a certain team lead, but highly interesting projects evolve where everybody is like part of the team and really supporting a project, which is far more fun. And then if you've got different languages at your table as well, it's even better.
I was also thinking about maybe other disciplines that are only emerging right now. For example, working also with neuroscientists and trying to, for example, understand the needs of the users on this a very basic neurological platform to. For buildings to respond in a different way to the way we interact with them.
Yeah, it's sure. It's also part of our future in a certain way, where we've got like two directions. The one is like buildings of the future are no tech, not even low, but just no technology anymore. Like at the moment, we are designing buildings without insulation, just solid. So you don't need this anymore. You don't need all these different materials in the building. But on the other hand, we are, say, so far already that highly complex infrastructures can be made very simple. And then we can use it again. Like we've got a research project at my institute. It's called the piezo. So with the piezo technology, we can actually start harvesting energy out of the facades just because the facade is moving a little bit. And we don't need any cables anymore. Right? So this is becoming fascinating that we say build a building, it looks like a building as it always looked like, but at the same time we're harvesting energy so we can switch on the light inside. So there's some high intelligence behind this facade or in this facade by chipping it, putting chips all over without cables that you can make use of and then start running a building. So also this is the direction which I really am fascinated in. So it's the highest technology, the latest research products being put into the facades, which can make a building interesting. Like at our institute, we've got 2 patents just for facades, and we applied for 5 further patents on a European level. But we know that maybe in 10 years' time, the market will be ready for this.
We have to design for the future. We have 2 comments from our viewers. One of them is just a comment, no proper question, about the table in St. Agnes. It actually really looks like it's always been there. Besides watching exhibitions, super interesting is exploring the building itself, and it's beautifully detailed. And the question about the Med University in Graz, how exactly do the windows open and close themselves when the sun goes up and down?
Well, the brise soleil is a system. There are engines, of course, for every brise soleil. and it's perforated stretched metal. And when the sun comes to the facade, we've got sun detectors, then the brise-soleil closes. And when the sun is gone again, it opens again. But you've got the possibility in every office and every lab to actually use the switch and open it if you want to see outside and you just get the sun into your office. So this is possible as well.
Okay, so it's powered mechanically.
Yep, sure.
Okay. Okay, so should any of our viewers have any questions, I would say that's final call for any questions. And so also my question probably about the Med University. You've mentioned that it has a very well, the structure itself and the plan is quite radical in terms that some of the buildings are, if I remember correctly, 6 meters narrow. And how do you compromise the functional program of a university basically with this radical plan that that you want to develop in order to make use of the natural winds occurring in this area?
So the one part was, of course, the microclimatic approach, and the other one is when you have a laboratory building, you usually have laboratories which have a certain dimension, and adjacent to it, office, parts of the office for the researchers. So they're always very close to their laboratories, and altogether this makes quite fat buildings. And we said due to this microclimatic approach, we have the thin buildings, so the air can actually go in between, but at the same time, we also have far more daylight in our buildings. So we asked actually to do these calculations if it wouldn't be more feasible to put them together, with having an office building and a laboratory building as one building. And we proved that this is actually more expensive than taking them apart, although there's more facade, but due to fire regulations and less use of electricity, less use of artificial lighting and so on, these buildings are actually cheaper when using them. Then on the top floor, that's the 6th floor, the whole campus is just for research. So there's an idea behind this that the institutes themselves or the professors can apply for research areas, and or maybe they got some grants or whatever, were successful in calls, and they can go into these research labs. And now this thing has been used for 2 years, and we're under construction with a new part, and we're already refurbishing the thing which is 2 years old, because there are new research teams coming in which need different spaces. So now they notice they can, because it's always a fat building, a thin building, a fat building, a thin building, connected with bridges. So all of a sudden they've got one part here, then they go to the other part with a bridge and another part here, so they can move around in this building and get incredible spaces. And they didn't see this before, that it is actually so flexible. And they're completely fascinated about it. And they can attract like international researchers because they can have all these facilities of especially space on these floors. So something which looks actually very rigid finally is highly flexible, but because of these bridges in between, I didn't explain this in floor plans, but all these buildings are connected with each other. So you can actually walk around the whole campus indoors, go through the bridges, go into the next building and so on.
Okay, and one final question that we have from our viewers. You seem to put a lot of attention to details and losing the scale of your work. And after your lecture, I can clearly see this tangibility, this attachment to form and material, and this sensitivity awareness to the environment. And what I'm most curious about is, what are your priorities while designing? What comes first? Aesthetics, economic issues, ecology, people, space created for them, or how well your buildings fit into the city?
It's hard to make a list of priorities in these criteria, but one of our main issues when starting the design, is to develop scenarios of utilization. when reading the brief, say of a competition or whatever, we try to imagine what are they imagining? How will this whole thing be used? Who are these people? And then we start imagining different kinds of scenarios. So maybe one building has got 40, 50 different scenarios, which we can sketch or whatever, or just talk about, but we won't tell anybody. This is our secret. And then we build it, and then we see actually how it is used. And sometimes there are different possibilities as well. So we're completely surprised by that as well. And the other things are like, I would say, add-ons. We can talk about details because our standard of detailing is very high. Maybe also our level of craftsmanship in the office itself is very high. We develop the facades ourselves, but we can also downgrade details, like a project I didn't show 1.5 years ago. We did an airport in Rwanda, in Africa, in Kigali, in the capital of Rwanda. And so we said we are not in charge of the site supervision. We don't know about the detailing down there. So we wrote a manual of like 100 pages, how they can build all buildings with very small amount of details. For example, of having load-bearing brise-soleil in concrete. So with having the load-bearing brise-soleil, the facade is clear. So what is behind the facade? Behind the brise-soleil, is it glass, is it brick, is it clay or whatever? They can decide themselves. All the slabs are the same dimension, all the floor heights are the same dimension, except for, say, the terminal building, the presidential building, and a few odd buildings, right? But all the others, like administration, hotel, it's always just the same detail being used all over. And this takes a lot of time to think about and to actually reduce it to, say, 10 different details. And you can build a greenfield project like an airport with, I think, 25 buildings with 10 details. It works.
It works.
It works.
That's great. Thank you very much for joining us today. Our guest was Roger Riewe, and thank you for taking your time to teach us a little bit on and explain your projects and your approach to architecture. So thank you to all of you watching for your patience and your comments, and stay tuned for next lectures, which are coming up in a couple of weeks. So
thank you very much for the invitation.
You're welcome, and have a nice evening and take care.